Case notes, day 3, or maybe 4, it's hard to tell anymore. This one is pure quantum, fragile states sitting in superposition, the kind that fall apart if you so much as look at them sideways, like a ghost that vanishes under a street light. Client wants error detection, clean and simple. Problem is, in quantum mechanics, detection always perturbs the evidence. Measure a qubit and you can collapse it. Meanwhile, the noise never lets up. So, what's the move when the evidence won't survive being detected? How do you detect an error without causing a new one?
Oh, cosa fai? Mi rovini il lavoro!
It's the notes you don't play.
What did you say? I've got it. Think of it like this. So, we want a way to measure a quantum state more gently, using less disturbance while still getting an answer that we can trust. Imagine you're trying to find a cat sitting in one of 8 boxes held inside a dark room. You can't see the inside of the room and you can't walk inside. One way to find the cat in this darkness is to install a microphone in the room and then spray each box with a water sprinkler from 1 to 8 and listen for an angry meow. But the room is noisy, so a single meow may not be reliable. Normally you'd repeat the test and take a majority vote to account for this. But there's a problem. The more you spray the cat, the more likely it is to panic and jump to another box. The act of measurement has changed the thing you are trying to observe. The smartest strategy is to use the first clear meow as your best guess. If box 3 meows, you assume the cat is probably there and stop spraying that box. Then, instead of trying to prove it by spraying box 3 again, you test only the other boxes. If they stay silent, your confidence grows that box 3 was right, without disturbing the cat again.
So we are using a negative result measurement. The absence of evidence is the evidence.
Exactly. In the real experiment, the cat is the nucleus of an antimony atom. It can be in 8 different states, which are represented by the boxes. The sprinkler is an electron that can hop on or off the nucleus to probe its quantum state. But, like the sprinkler, the probe can disturb the nucleus, making it jump to a different state. This is brilliant. How did you come up with this?
It just came to me. So using this protocol, we can measure the quantum state with much less disruption. It will more than halve the chance of a measurement error and reduce the measurement time by a factor of 3. And all it takes for this to work is being able to adapt our strategy during the experiment. Like a good investigation where you change your strategy when you get an important clue.
Most importantly, it achieves a confidence of 99.61% in identifying the correct state.
The case wasn't about errors, it was about restraint. The kind that keeps your hands steady when the truth cannot take pressure. Future quantum machines, they'll have to detect faults mid-calculation inside the work itself. Like reading a confession where the ink is still wet and the paper might dissolve if you breathe too hard. I left thinking not about what cannot be done, but about what might finally become possible.